Okay, so I think Eliana introduced me completely, so I don't need to do much of introduction. So I'm Noushin Khosravi, Sustainable Construction Manager at MPA. I'm going to cover a bit of what's happening in general in the UK concrete sustainability area, and what are the initiatives going on, and what are the areas that we are focusing. Some stuff might be a bit basic. There's not much time to go to great deal of detail about every one of them. As you know, sustainability is a very hot topic at the moment. It's very important, and it's very difficult to put everything in half an hour, 40 minutes. But I'll try my best, and I'm happy to have a conversation about any of the items you want to know more about. Just covering a bit of basics. What is Mineral Product Association? So for those who haven't come across MPA, we are the UK Trade Association for aggregate, asphalt, cement, concrete, dimension stone, lime, mortar, and silica sand industries. We have a growing membership of 530 companies, vast majority of SMEs, quarrying companies. We cover 100% of UK cement and lime production, and 90% of aggregate production, and 70% of ready mix, and also precast. As you can see, important industry in terms of economy as well. Why UK concrete is really important, as you can see, and I'm sure it's many of the countries is the same, concrete is a local material. This is important context because it has a domestic market. So, and it's a supply chain that is verifiable and is responsibly sourced. And what I mean by responsibly sourced, because we can see that we can control the quality, we can avoid slavery, we can have a good control of the supply chain. And also in terms of travel distances, it's very short travel distances, it's traceable, it's a supply chain that is accountable, and it's everywhere within the UK, basically. You can see on the map, the dots is showing where the industry sits. So again, UK concrete is a key part of the wider mineral product industry, contributes 1.8 billion to UK GDP, directly employs 81,000 people and 3.5 million jobs.
Opa, tem alguém com o microfone aberto aí?
Sorry, Brito. Your microphone is open.
It's okay, Noushin, now.
Sorry,
Yeah,
Noushin,
right,
sure,
okay.
sorry.
Okay, and so as you can see, sustainability of concrete so can be very wide topic because it has really big social impact within the UK as a social economical impact. So that's why I'm going to do a sort of overview of all sustainability sides of concrete within this presentation. Why choose concrete? I know most of you who are here are concrete sort of fan, and you are into concrete industry. So, you know, it's really important to deliver new homes, school, hospitals, infrastructure with concrete. And it's important to protect communities, residents and buildings against threats of fire, flooding and changing climate. As I mentioned, it's sustainable, local, responsibly sourced, and it's really important for the UK economy. And also it can play a role in innovation and advancement of technologies. Some other benefits can be, as I mentioned, like for the climate change, for sound insulation, for thermal performance, and many, many others. So it's really, really important material. I'm sure you are familiar with Professor Karen Scrivener. She had a talk a while ago that she mentioned a really important point. There is nothing that can replace concrete. It is intrinsically low CO2 material. It only makes such an important contribution to CO2 emissions because we use such enormous amount of it, which is really true. The volume that we are using concrete is the second most used material in the world. So, and she had a sort of estimation, if you want to replace 1/4 of cement with timber, you need to plant new and sustainable forests of 1.5 times of the size of India. So we really don't have any other option rather than concrete at the moment to use. So it's important to focus on its sustainability aspect and make it more sustainable and reduce its emissions as much as possible. So what did UK do in general? From 2008, UK concrete industry agreed a sustainability strategy and committed to deliver some targets based on that strategy. The strategy evolved in 2012 and set the targets for 2020. And at the moment, we are working for the targets to 2030. So it's important as a trade association, as industry, to have these commitments and reporting and the vision in place in order to be able to measure, to deliver, and plan for actions. So the reporting side of it and the data is really a foundation for sustainability and any action that we want to take forward. From 2008, so the industry started to report on many different indicators. I'm not going to go to the detail of the indicators, just mentioning them basically. So the carbon emission and production and emissions excluding CO2, as you can see in the graph, that's how we can show how the industry from that time has started to reduce its carbon emission and energy efficiency and all other sorts of indicators. So these are more of a sort of energy and carbon indicators, but it went more than that. We looked at environmental management systems, how we are reporting the environmental management, what are the certifications, and how the manufacturers can improve in terms of environmental management. Resource efficiency. At the time, probably the concepts of circular economy that we are becoming more and more familiar with it didn't exist as much. So most of concepts of related to circular economy were defined in this with the wording of resource efficiency and waste minimization. And that's how the industry started to measure its performance in terms of efficiency and waste. And quality, transport's really important part of emissions, especially for aggregate side. And then water and biodiversity, again, especially for the quarrying side of production of concrete, really important parameter. And it's been great success through the time about quarry restoration programs and having biodiversity net gain at the end of the quarrying program that the industry has been reporting on that. Responsible sourcing, employment and skills, health and safety, and local community, also the social aspects of the indicators. In the UK, we have BES 6001, which is a standard for responsible sourcing of material, and a lot of reporting has been done based on that. And most of our... The BES 6001, is that correct?
Yes, yes, we did.
Okay, good. So I'll continue. So having said that we have been reporting on the sustainability aspects and everything, obviously the commitment that we are having for reducing emission is really big and we are taking it serious. So we are making more commitments to go forward. Looking at the carbon emissions specifically, reduction in absolute CO2 emissions has happened since 1990, about 53%. And if you look at the graph, this is more than the whole economy in the UK, which has been 43% at 2018 baseline. Just the graph on the right is also showing the, so we know the global contribution of the cement and concrete industry in the emission is about 7 to 8%. but in the UK is about 1.5%. Still a big contribution, but slightly less than other like global figure, obviously. So this thing has happened through a lot of efficiency, changes of technology, the cement production, and using supplementary cementitious material. But the industry knows that we have a big challenge of process emissions in place, and there is still a lot to do to reduce the emissions from cement production and concrete production. I'm not going to explain about how we produce cement. I'm sure people in the room are familiar with the cement production and what I mean really with process emissions, which is what happens when calcium carbonate, we heat it up and the carbon side of it is emitted, and we can't really do much about that process side of it at the moment. But there are combustion emission side of it that there is a lot happening at the moment. So the roadmap, UK Concrete Roadmap, was published in 2020 with many lever papers to explain each part of it. If you look at the roadmap, it has 7 levers to go beyond net zero. So the levers are about indirect emissions from electricity, transport, low carbon cement and concrete, fuel switching, carbon capture, and then looking at the beyond zero benefits of concrete is carbonation and thermal mass. What I mean in beyond zero, it means like we are not counting the benefits of concrete in terms of carbonation for achieving the net zero within the UK. But we know other roadmaps like GCCA roadmap is including that carbonation in there. Also, there are different roadmaps might have other levers like efficiencies in the structural design and construction, but this roadmap is very much focused on manufacturing side and what can happen within the sort of MPA environment. But we shouldn't ignore the other sort of carbon reductions that can happen within the construction industry. What I'm going to kind of focus here is more about low carbon concrete side of it and fuel switching. Indirect emissions from electricity and transport are really important part of it, but it really depends on government and availability of renewable energy in the grid to be able to use the electricity, and also transport a lot of infrastructure that is required to make that change. So we are, my colleagues at the cement side of it are working with the government to make sure they can have those sort of commitments happening within the time that we want. But it's a sort of more larger scale part of the country anyway for having this infrastructure in place. Also, I'm not going to focus on carbon capture because it's another big topic. It needs this whole session to just talk about carbon capture. To just give you a bit of idea, we are hoping by 2027 there will be a 1 carbon capture infrastructure in place in the UK, and there are plans for more than that happen. But there are many challenges within carbon capture as well, and my colleagues are working closely with the government for the policy and investment requirements for make it really happen. So if I want to just focus on fuel switching, so the fuel for producing cement is coming from fossil or waste biomass at the moment. 45% of thermal input to UK kilns is provided by waste drift fuels, and this includes, as I said, waste fossil, waste biomass. 18.5% of thermal input to UK kilns is provided by waste biomass, and 609,000 tons of waste drift fuels were consumed by the UK cement sector in 2021. And this is important to consider both from point of carbon emissions and also from contributing to resolve the problem of waste in the country. So there is also the co-processing side of it, which I think is more important from circular economy point of view, that the ash from fossil and waste fuels beneficially forms a part of the mineral content of cement and does not become a waste residue. So there is basically almost no waste from cement production. And cement manufacturing therefore upcycle the mineral content of waste with energy recovery as a co-benefit. And this is the number that you can see about the tons of fuel ash from waste fuel is recycled into the cement. So this is about what's happening within the fuel side. And these are the example of some fuel switching and what type of materials at the moment are being used as waste into the program of fuel switching. But another side of fuel switching, if you want to kind of see how that 16% reduction might happen. So there are like different aspects in there. There should be the supply of waste biomass available. So the roadmap expects 70% waste biomass will be available. And then efficiency of the production and manufacturing is really important. And the infrastructure, especially for delivering hydrogen, should be there to enable that fuel switching to happen. And if these things are in place, we believe by 2050, there will be 16% reduction of emissions through just fuel switching. How we are helping this to happen more? So with the partners, we had some trials going on with the government-funded funding partially side of it for hydrogen, using hydrogen for basically producing cement. This was, and also plasma. This was a good demonstration that it is possible, but there and also highlighted a range of challenges about hydrogen delivery and the efficiency of using hydrogen. And we know the availability of the right type of hydrogen in place to make it happen. But this is a good step to just show that it is possible for the industry to switch to using hydrogen. But then the rest is about having the infrastructure in place to make it happen. So if I move on to low carbon cement and concrete, as an overview, it's about clinker content, it's about innovation and research being in place, and how we work with the standards, how we can replace some of the cement as CEM1 that we call it in the UK with other supplementary materials or additions, and how we help innovation to go forward. And we expect 12%, or actually even more, we guess, will happen through using this lever. 12% of reduction will happen through this lever. So I'm going to go more and more sort of detail about this. So I think for low carbon concrete production and use, there are different aspects or elements into it. One of it will be supplementary cementitious material, alternative clinkers, how specifications and standards will kind of keep up. Then efficiencies in design and construction, benchmarking and definition, and procurement policies that needs to be in place. These two efficiencies and benchmarking, as I mentioned, is not covered in MPA roadmap, but there is the ICE low carbon concrete group, which we have been heavily involved. We call it low carbon concrete roadmap. That is covering that side of it. I'm going to explain about it in the next few slides. So starting from supplementary cementitious materials, everybody knows that the highest emissions are coming from cement side of it, and also reinforcement. The figures that I've mentioned here are slightly old. We have recently published a new sector EPD that our average sector EPD for cement is 840, and the steel reinforcement also, the figures are changing and are lower, the new updated figure, which we will update in our documents by the end of the year, all these figures. And using secondary cementitious materials, we know like fly ash, GGBS, limestone. If you can see, all the figures of the carbon emission are much more lower. There are lots of discussions about if the figure of GGBS should include economic allocation from steel. And this is ongoing conversation within the UK. I think by the end of the year, again, we will have a new higher value for embodied carbon of GGBS, but still that value will be much lower than what we have for CEM1. So still makes sense to use GGBS in the concrete for reducing carbon. So typical UK cements blends that is allowed in the standard at the moment. You can say it depends how do you compare it. If you're comparing with CEM1, it can be a lot of opportunities. Already 65% cement replacement is possible, and a lot of carbon reduction, as you can see, it's possible. But we know that we are relying a lot on GGBS and fly ash, and we need to change the standards and work more to find other sources of material to be able to use in the future. That's why we are looking at what would be the other innovative materials that can be a part of our large scale sort of recommendations that we give to the industry. So how we can choose which material is the best to use. So one of the most important part of it is the raw material availability. Is it from waste or it's coming from natural resources? Obviously, we would be happier if it's coming from a waste industry, waste streams, because then it has a good impact on the circularity of the materials and we don't need to damage any natural resources. Is it local or imported? Again, obviously local has benefit. It has impact on social aspect. It reduces the carbon emission from transport. So if we can find local material, is better. What's the CO2 mitigation potential? What is the scalability? Is it at the research level? Is it the pilot, demonstration? How we can commercialize this? What's the impact on consistency of concrete, other properties of concrete, the strength gains, durability? What would be the preferred application? What would be the impact on water demand and energy demand? How we can change the standards to make it to be people to use it? And what would be the impact on the cost? So there are a lot of criteria to really be able to recommend another additions or supplementary cementitious material to the market in the UK. So what we are doing at the moment, one of the kind of most available materials in the UK is limestone. The standards, the UK standard BS 8500, doesn't allow you to use more than two components, like one CEM1 and one addition to CEM1, like GGBS or fly ash. So my colleagues have been working closely with the standard committees to change that sort of two component to be a multi-component cement. So we can add some limestone now and make it like ternary blend. The benefit of using ternary blend with limestone is the limestone is available at scale in the UK. And then it will help us to optimize use of GGBS and fly ash because we know there are limited resources. So at the moment, we have proved through the research that and testing that up to 20% limestone is adding to the concrete. It will actually it will give us a general purpose cement still, and we can mix it with another like 40% GGBS, and we will have equivalent performance as we would expect, for example, for a 60% sort of GGBS mix. So this is a great opportunity for lowering carbon across the UK. So we expect over 4 million tons of CO2 annually will be reduced just by introducing about even 15% limestone into the oil mixes of the UK. And the good thing is the supply chain, the manufacturers are ready to, are all prepared. It's not difficult for them to be to basically provide that to the market. So the new standard will come up, I think, in November time, and that's a big milestone for UK industry and giving us a bit more options and opportunities to provide low carbon solutions. Another project that we are working on is reclaimed calcined clay cement. So as I mentioned, we would like to use waste streams as much as possible. So this project is looking at clays from waste, from demolition, bricks, and seeing what would be the source of clay that we can use within the UK. We are looking at 10 different sources of clay and starting to understanding their characteristics and the grinding process and heating and their reactivity and all sorts of tests that we need to do before being able to offer it to the market. So calcination and recycling is happening, and we completed the calcination of or flash calcination or the rotary trial were all finished in January 2023. And now we will start a phase of durability testing to see what would be the impact and what proportions of clays that we can use for achieving the right durability of the material. So reclaimed calcine, as I mentioned, it needs a lot of work. We need to understand the characterization. We need to understand the rheology, reactivity, strengths, and the impacts. So it is a complicated sort of process to be done to find the right source of clay. But we are hoping in the next year we will finish this project and we will have the recommendations in place about the source of clay. Recovered PFA or fly ash is something that we are also looking at. So UKQAA is UK Quality Ash Association. Their estimation is over 100 million tons of recovered fly ash might be available, which 40 million ton of it can have cementitious applications. So we are doing another project with University of Dundee to understand the characteristics of this stockpile fly ash and also its impact on durability again. So this will again open a big opportunity for using supplement like lower carbon solutions and being able to offer more options to the market. Recycled building materials. So EN 197 in the Europe is looking at recycling cement paste. It hasn't started in the UK, but we are thinking of we should look more seriously into that. I think the EN 197 is looking at up to 20% replacement of the cement being allowed within the standard. So we think this is a good opportunity and we should look into it in the future. And it's in our sort of to-do list in the future to look at it. Other natural pozzolans, so volcanic origins, it really depends on the country. There is not much available in the UK. If anything wants to come in the UK, it will be imported from other parts of the world. And it's up to our basically probably members to decide to import it. In terms of sedimentary products, natural clays, for example, there are projects, major projects that they are looking at natural clays, for example, London clay, as they're excavating for a project, they're thinking how they can use that clay. So it's happening. It's not within the remit of MPA at the moment, but when their project finishes, obviously it will have an impact in the whole UK and it will be another offering to the market. And generally natural pozzolans or even waste pozzolans, we think they will have a good impact on durability. There might be some challenges with workability and stuff, but anyway, there's not much concern about having like a negative impact on performance. So alternative clinkers or niche cements, there is a lot happening in terms of innovation in this area. Geopolymer or alkali activated binders, it's being used now in the UK. Many different companies are offering that. The problem again with these geopolymers is the highly reliance on GGBS and fly ash, but we know that most of them are also looking at activating calcined clay, which is a more abundant material. But there are other alternatives. I'm not going to read the list for you, but we consider them as more of a sort of niche cement. Might have a special application. Most of them are not really commercialized yet. But having said that, we should still look at the innovative other possibilities, because there is no silver bullet to resolving the carbon emissions, and maybe all these bits and pieces can contribute to the carbon reduction anyway. And then there are other innovations that I'm sure everybody is aware of that, like self-healing, graphene enhance. They might not be directly working in terms of carbon emissions, but they improve performance, maybe lower volume of concrete will be used, for example, with graphene enhanced concrete. So they will have some sort of indirect impact to reducing the emissions. And so it's really important as MPA, we are supporting all those innovative products that are coming out. So this was about the materials itself. But the specification and concrete standards are really, really important. That can be actually a major obstacle to innovative materials, because we don't have long-term performance data, and they are not compliant with European or UK code. So it's difficult to use any new material, even if they become commercialized. So that's why we think the performance-based specifications are really important to replace some of the BS 8500 prescriptive approach. So, but the performance approach is less mature and it still needs a lot of testing. So the low carbon concrete group that we are part of it, and MPA Cement is also funding this work, is BSI Flex Standard project. This is it's called Flex Standard because it's going to kind of come out a little bit faster than the normal technical committee reviews that the BSI standards go through. So if it's achieved the consensus, then it is assumed that it's okay and it can come up. So this Flex standard is going to be a performance standard, and it's going to tell us how to demonstrate the suitability and the level of testing information required to use a new technology, a new innovative technology. And our estimation is by 2025, this standard will be available in the UK, and it will facilitate use of new technologies and lower carbon solutions, which are not in the sort of traditional UK concrete standard. Having said that, so we are developing a new standard, performance-based specification, but we think it's really important to look at what we are using as a standard now, the BS 8500, because BS 8500, it was published like 20 years ago. And since then, there has been improvement, for example, in cement quality, the water reducing admixtures. And at the time, it was written in the context of durability mainly, and carbon was not as much on the top of the agenda. So there was not much concern about the volume of cement that is being used within the standard. And this standard has limiting values that connects the water cement ratio, the cement content and the strengths and covers kind of together. So it's really important if we can review this standard in the context of carbon, maybe we can actually relax some of the requirements and use less cement. And finally, we will have actually a better lower carbon solution. So that's why MPA funded a desktop study or review with Mott MacDonald to look at basically review the history of BS 8500, our concrete standard, and understand is there any possibility, is there any evidence that we can reduce and relax this, for example, cement content requirement. And the report is now finished. So Mott MacDonald looked at the history as evolution of BS 8500. It looked at international standards and how they are kind of specifying concrete, and has come up with a list of recommendations and evidences that a lot of requirements can actually be relaxed. And this is what we are actually taking to BSI committee, which is the standard committee within the UK, and kind of proposing these changes to relax some of the requirements. Probably they will ask for more testing to prove, and then we will go and get some funding or with people who might be interested to get involved to do the testing. And then if this relaxation within the standard happened, we expect a lot of, I don't have a percentage exactly of how much reduction will happen, but there will be a big reduction with the carbon emissions of concrete. So coming from material and standard, now how we can really procure a lower carbon concrete. What are the requirements? If we have all the material place, we have concrete standard in place, but how we can ensure that we are using a low carbon solution. So Mission Possible Partnership last year published a document to look at a sort of a framework for procurement of concrete. So this framework kind of shows that there are required foundations before the policymakers can set a policy and facilitate procurement of low carbon concrete. And in this foundation, it looks at the data collection, databases, baselines or benchmarks, then disclosure, carbon limits, and economic incentives. I'm not going to explain all of them, but I'm going to look at the standards and data collection, product baseline, project baseline, and carbon limits a bit. So standards of life cycle assessment, it's been a while that they are growing and they are being refined. At the moment in the UK, EN 15804 is the most acceptable standard for producing EPDs and life cycle assessment. So it seems that the standards are picking up. They are getting ready for us to help us to measure and report our carbon emissions better and more accurate. So data collection or carbon disclosure, as I mentioned, as MPA has been disclosing the sector carbon emissions, but then looking at EPDs and at the product level, then the manufacturers or even the contractors or designers can disclose this data. Then products, this baseline will be the current industry average based on strengths, for example. So EPD, as I mentioned, is really important, is the fundamental step to be able to actually reach to that sort of policy requirement and setting policies for carbon. So as an MPA, we are producing sector EPDs, like our average country sort of EPDs for selected ready mix, masonry, and precast product. We want them to be third-party accredited, so you can rely on that. So it's a big work for us to produce that sort of average industry EPDs. But ICE low carbon concrete route map that I've been mentioning since beginning, they also looked at a sort of wide range of recommendations for the value chain, from clients, from contractors, and kind of supply chain to what they can do to provide the right data and kind of reduce the carbon. One thing that they published, and it's got a lot of attraction, was the benchmarking of concrete based on strengths. So this is something that I think worldwide probably is the first country that produced this sort of benchmark. It's probably similar to what you can see on your fridge or washing machine in terms of A to G energy efficiency of that product, and you would give you a little bit of confidence. If you are in the red zone, it means like it could be better. It's a bit of a like higher carbon, but if you can come lower and lower, is obviously better. But this is based on strengths and showing the carbon emissions, and the plan for ICE, for low carbon concrete group, is to update this annually to kind of show what's the status of the market for that year, or actually the year before, because the data is coming from the last year. So this would be the product baseline, but we understand the project baseline is also really important, because you can't have just product baseline. For example, you choose a very low carbon concrete, low strength, but you use a big volume of that concrete. So if you are not looking at the project level or the building level, then you would lose the sight. Then it will, at the end, will be a higher carbon solution. So that's why we think the project baseline and product baseline should be together. We cannot look at one of them in isolation. So that's why UK Net Zero Building Standard is also looking at benchmarking and setting limits and targets at the building level. And I like their sort of graph explaining what is a benchmark, what is a limit, and what is a target. So they say the benchmark is the current sector average, limit is the maximum performance level that must not be exceeded. So for example, for a product, there should be a limit of carbon. If the product is higher than sort of that carbon level, it shouldn't be used, basically. The target is the best performance, or where we think is the minimum performance level that must be met or exceeded, basically, ideally. Example of enabling of these limits and targets can be mandatory product standards. For example, if the government decides that if any product is higher than G level, it's banned in the market, then that would be a mandatory product standard. But ideally, as the industry, we would prefer the voluntary product standard, something like ICE has already produced that can help and incentivize and kind of encourage people to use lower carbon solution without banning a certain product. Then at the building level will be UK Net Zero Building Standard that I mentioned. There is another standard for future home that is going on. And recently, the science-based target also mentioned a guide that they are producing and a consultation that is going on for building science-based targets, which is another important thing to consider. But that as MPA, we are more involved in the product side of it. That's why I'm going to explain a little bit more about voluntary product standard. So voluntary product standard, or that LCCG concrete benchmarking, will help the practitioners to define low carbon concrete. Then it will incentivize and accelerate adoption of low carbon concrete. It will set the benchmark and will help to set the target. And then you can also report against the benchmark. The clients can define the product's requirement benchmark and also commit to buying certain level of embodied carbon of products. And also these graphs can show over time how the sector is decarbonizing and how these graphs are kind of little by little are being moved down. So it shows how the sector is making progress in decarbonization. So how MPA is supporting this benchmarking activity? As I said, we have that disclosure at the sector level with our reporting, but we also collect data for LCCG benchmarking, which is that low carbon concrete group. At the moment, it's based on just ready-mix data. I should mention, we are aware that for concrete is not the best approach to look at just the strength and the embodied carbon, because the application and the exposure condition makes a really big difference about what you choose for concrete. Also, even the regions. For example, if in some part of the country, the quality of aggregate available locally is not that good, you might end up using more cement, but you can't do anything about it. You will have a higher carbon embodied carbon of concrete. So if you want to compare it with the sort of just the strengths benchmarking, then it will not fit in there as a low carbon solution, but it's a low carbon solution for that region. So we understand there are lots of shortcomings with this current benchmarking, but it's a good starting point. And another sort of challenge we have is as the manufacturers, we cannot provide that data about application, because our members would know like what they produce, but they wouldn't know how it was used exactly. They will have some ideas, but they wouldn't know how much of it went to a pile or how much of it went to a column. So the application data should really come from the contractor side. And they need some tools and some kind of planning in place to to record all of that correctly and be able to communicate that to this kind of benchmarking, to make the benchmarking more accurate, let's say. But anyway, we try anyway to provide the data from ReadyMix at the moment. And we also make sure the consistency of measurements, because within the standard, there are many options for measurements that you can consider. For example, for cement, is it net or is it gross? Are you considering like waste fuels, or you are not considering emissions from waste fuels? Both are allowed, for example. And within the calculation, there are many options. So we, as a trade association, we are trying to help our members to choose one methodology and be consistent in their carbon calculation. So we make sure what we are reporting as an industry is really comparing like by like, is comparing apple with apple, basically. So it's really important part of our work as the trade association to assure that consistency of measurement. The sector EPDs is another thing that can be a point of comparison, because it's again the sector EPD will not cover the whole range of concrete. It's a lot of work for that, but it will be a point of comparison to show if it's kind of working okay, the benchmarking. Then tools are also important. We are facilitating use of tools like one-click LCA that is kind of available in the UK for our manufacturers, to our members, to be able to use that. And we provide some sort of floating licenses for them to use them tool to produce their EPDs. But a lot of other things. We really support this benchmarking because it's an important measure to define the low carbon concrete. Having said all of that, for reducing carbon and what we can do, we shouldn't lose the sight of retain and use the structure as much as possible. This should be the first recommendation coming, and this is the best solution for reducing our emissions. So we always mention that. And even if it's at the end of first life and you really have to demolish, then we should make sure there is no waste. And we claim as an industry that we are close to zero landfill waste, and all the waste from concrete demolition is being used within the construction industry, which is a great step. But ideally, it's better if it's more upcycled as well, not just recycled and used in other application. And just mentioning that so we don't lose the sight of reusing of a structure as the best strategy. Just the last slide. So at MPA, we think it's really important to work with the value chain. So me and my colleagues, we have a lot of stakeholder engagement activities. We really get involved with different groups, different initiatives. We want to make sure there is no binary sort of mindset of good and bad material. We think this is not helpful, and it's every lower carbon solution, and it will have its own sort of application. And we support the clients, their teams, the designers, the contractors to kind of be up to speed with what's happening within the industry. And we remind them the early engagement with the supplier team to specify the lowest carbon solution is really important. We also work closely with the government in many different aspects of policies. We have developed a lot of policy asks to enable the manufacturing side of it to become a lower carbon manufacturing process. Also, for example, including carbonation of concrete in the inventory of carbonation within the UK. This was a project that we did to calculate exactly what's the level of carbonation that can be included in the inventory of carbon of the UK. So, as I mentioned at the beginning, there is a lot happening. I hope I managed to kind of give a quick summary on the area of low carbon concrete. We are doing a lot of initiative around developing a framework for circular economy, developing a framework with a consultant for social outcomes and metrics, refining the metrics on that side of things. And my colleagues are involved. In the UK, a lot of initiatives are going on. So we try to be involved and make sure the concrete is included in the conversation, and the right information about whole life carbon assessment, EPDs, and everything else is being communicated correctly. Thank you for listening to me, and I'm happy to have a conversation if there is.
Oh, thank you, Noushin, for your clear and inspiring presentation. Now, I would like to invite Professor Vanderlei John and Carlos Mascato to a Q&A session, okay, with you. Please, Mascato.
Okay, I think I can start. It was really good presentation, Noushin. Thank you very much. Very comprehensive. I'm very impressive. I've been following MPA from quite some time, and you have been improving a lot. I think you have an excellent agenda, very comprehensive. Nobody has something as systemic and coherent as you have. I think it's very, congratulations for the work.
Thank you.
But
Good to
then
hear
I have a question.
I should tell my colleagues.
No, but you are part of it, and I think it's a terrific job. You have to acknowledge that. But I have a question of my own, you know, that I think the cement industry has been built on reactivity. We make cements to be reactive, so we search for reactive stuff. But there is very easy to understand that we can, if the cement industry starts playing with the water demand. So if you make cements that demands very little water to make a flowable mixture for a concrete or a mortar, whatever, you can reduce a lot the need for reactive fraction. In other words, you can use a lot of fillers. And I'm not talking only about limestone filler. I'm talking about any filler or poorly reactive 100 years old fly ash, or like 200 years old slag that you have in Redcar and other operations that have been shut down around in the UK. So just so you know, we started a research project as a cooperative research project in our Hubic, that we have quite I think 6 cement producers, and we are exploring the route of a cement that comes with a super plasticizer. And because you reduce the water, so you can increase the amount of filler. And that's something that you have any, we had any discussion on that subject, to create a new class of cement, or we are just focused on what the traditional way?
So I'm not aware of like a project going on for new class of cement, but I mentioned about we're reviewing the standard, our current standard, that's seeing like, okay, we have a more powerful water reducing admixtures now. So probably we have been very conservative 20 years ago for the cement content that we thought is the best. So now I think a part of testing for proving that some of the requirements can be relaxed for the current standard will be actually looking at water cement ratio and the impact of admixtures. But I don't think we're going to look at like new type of admixtures more than what is available in the market now. It will be just seeing like, okay, the admixtures are better now. So maybe the cement requirements are actually less than what we thought 20 years ago.
But what we are talking is the admixture is part of the cement formulation. It's not,
not doing that.
Optional. Okay, but then so
it
we
would
have
be good to know how you progress. It would be good to share that with us.
Oh, it is a very simple project. It's not really a complex one. The problem is usability. We have a question here from Rafael Pileggi, my colleague from USP, in asking for you about, in the case of systems with limestone filler, the concrete that we are talking, and the new cements. Are you playing with particle size distribution, or just and measuring the rheological performance of cements, or just keeping the way it is nowadays? It's basically the same question that I made you formulated in other way.
Yeah, unfortunately, I don't know the detail of like what is the particle size of limestone that we are offering, but I think it's, again, because these projects are looking at not something niche, they are looking at what can be done with what is available now. So I assume these are like a kind of whatever limestone particle size that is available and being used normally in the market. So we are using that in the mix. So it's not innovative, sort of, let's say. It's just about opening up more opportunities to use more cement, and the standard allowing more different types of component, like mixturing of cements, and the standards allowing it. It's not a sort of niche innovative type of like grinding of limestone, or like using it in a very different way, let's say.
In this, that means just a curiosity, Masukata. Then you can go. It's because in UK you have like ashes resources and eco cement. You had a long tradition of selling SEMs directly to ready mix company, to concrete block producers, to even
Yes.
building contractors. So you are discussing the possibility of selling limestone filler directly to building contractors and ready mix. This is what you are discussing. So it's going to be a SEM standard for limestone filler that can be mixed at the construction side of the ready mix. This is one possibility.
Depends. Like if the batching plant, for example, have 2 silos, we assume one of the silos can, by default, can be a limestone mix of CEM1 or cement and limestone. We call it CEM2AL. So it can be one silo, like, I don't know, 10% limestone with cement, and another silo can be GGBS. And when they mix a ternary blend, basically. Or if they have 3 silos, a batching plant, then one can be limestone, one can be GGBS, and one can be Portland cement, and then they can mix it together as they want. So,
thank you.
but the standard was not allowing us to do it before.
Yeah.
So now we
no,
can
it's fundamentally different from our market. We don't almost have no secondary SEM sales in Brazil.
yes.
Are very low.
Yeah, I think it's very unique for UK markets, because cement blends are not produced at cement plant. They are produced at the batching plant.
Yeah.
Noushin, I have more 2 questions. The first question is from Walter Frigieri, the Brazilian Cement Port Association. How have cement and concrete players been involved in innovation challenges? And the second, do they have their own research, or do they work in a consortium?
So they definitely, they are, most of the cement producers are the international cement producers. They might have different name within the UK, like Holcim might have aggregate industry name in the UK, but they are kind of part of the international cement producers anyway. We just have, I think, one solely local UK cement producer in Breeden. That's the only one. And they all have their own research going on, but I think as MPA, we just try to kind of bring them together and open the door for like new research for the UK specifically, let's say, because especially in their headquarters, which some of them are not in the UK, they do a lot of research and innovation. They're investing a lot, obviously. I wouldn't know the number, how much they're investing, but definitely they are doing it.
Okay. And the last question that I have in the Q&A, and my question: how does the government encourage the use of eco-efficient concrete? And the second question: and the construction has an incentive to use eco-efficient concrete in the UK?
So I think after the UK net zero building standard kind of develops and become like published, basically, I guess IStructE, which is the Institute of Structural Engineering, they are planning to kind of discuss it with the government to consider as sort of those limits and those targets that should be met at the building level. So I think that would be the kind of regulation or incentivizing the efficiencies, basically, because if you want to achieve it at the building level, you have to optimize, you have to be more efficient, as well as using low carbon products. So that's my understanding. I guess that's going to happen.
Okay.
So,
please, Vanderlei.
no, Seiichi Suzuki from Intercement is asking, is the consumer, the end user, demanding low carbon concrete or low carbon buildings, or is just the government in the UK?
So yeah, just going back to the previous question, actually the whole life carbon assessment, the government is trying hard to make the carbon assessment kind of mandatory and kind of making it a part of the whole planning and things. So I don't miss that. But yeah, in terms of pushing for like demand side, so the government has set the net zero target for 2050. And then most of the publicly sort of infrastructure projects are actually government funded. But there are different like names for it, like national highways and HS2 and others. So they are sending a really like strong demand for low carbon concrete. But I think especially the big developers of buildings and more private side of it also are under pressure to meet their own carbon emission targets. Because if they are not involved in this conversation, they will lose credibility and it will be damage for their reputation. But I'm not sure how it works with really small contractors. Probably they will struggle in terms of program and cost to include these kind of conversations in their sort of construction program and demanding lower carbon solutions. But definitely larger projects, it's really the strong demand and questions about low carbon and setting targets and limits and kind of trying to meet them within the project. I hope I answered the question.
I received more questions here. Mrs. Rubiani Antunes, do you see any possibility of having carbon credits for projects that incorporates all the tools that you presented?
Sorry, which tools you mean?
The tools that you use to calculate the carbon credit in UK.
So the question is, do you think carbon credits or it's going to be part of this driving force to promote low carbon solutions in concrete in the UK? It's we have a benchmark, and I'm doing much below the benchmark or below the target, so I can put in the market this difference. This is the CO2 market, the carbon market in the EU applies to construction. Are you dealing with that, or you are just ignoring this?
Unfortunately, I don't know much detail about how the carbon credits sort of, you mean the finance side of it?
Yes,
you
the
mean?
money.
Yeah.
So I can sell carbon. Someone is doing bad, they can buy it.
I'm not on top of that, unfortunately. There might be things happening, but I haven't come across much of conversation about carbon credits and the finance side of carbon. I know that, like, for example, offsetting, which I don't think it counts. It's like kind of
It's the same. It's the same.
Yeah.
Offsetting, you need to buy from someone, so it's offsetting.
Yeah. Offsetting, I think it's not included in our roadmap for sure, and we don't encourage it. And we prefer to work on carbon sequestration instead of offsetting as much as possible. So we as MPA, we don't really encourage and kind of work on that side of it. But it doesn't mean that it doesn't happen within the UK construction. I assume it's happening. I think there are people have put really difficult targets for 2030 and they cannot achieve it without offsetting. It's impossible.
Yeah. Some strategies are built on that. That's a problem.
Yes.
Vanderlei, do you have more questions here?
No, I think it's time to go. This is Friday, 5:15 for Noushin. She has to go to the pub, I think. It's time to go
it's
to the pub.
2:15.
2:15, okay.
Yes,
It's
not too bad.
Okay, we have more. The last question from Walter Frigieri. Have regulation and narratives changed the market share between steel, concrete, and timber?
Oh, well, I don't know exactly how the market share of it is working. We have the annual sort of quarterly actually reporting on the market, but we don't compare it with timber. We just say how is our market. We report that. I know there is a lot of attention to use of timber in the UK. But the problem is UK doesn't have much of domestic or local timber available, and they have to import it. And then assuring that it's coming from sustainable forests and all sorts of things, and also the transport. So there is lots of conversation. A lot of people are kind of without considering looking at the whole life carbon solutions and looking at really where the material is coming from, might be kind of preferring timber or advertising for timber or lobbying strongly with the government for timber. So it's a lot of work happening in terms of conversations and lobbying and these kind of things, but I wouldn't know what's exact market share.
It's growing, but it's growing from zero, so it is really, they are growing a lot.
Yes, it is. It is for sure.
But I think we should end our. It's time to end. It's I think has been excellent. I'm very happy to have you here. I think everybody
Thank you for the chance.
Really excited. Hope we can catch up sometime again in the benchmark or whatever. You can come to Brazil eventually, so it will be
I would
nice.
love that. I've never been there.
Eli,
thank you.
Finish.
Oh, before you go, Noushin, we would like to take a picture. It's okay?
Okay, yeah.
Okay. Smile, everyone. Okay. Okay. Noushin, thank you one more time for your for sharing your experience. And now we're gonna present our next activities. Feel free to stay with us.
Okay. No, I'll just leave if that's okay. Thank you.
Okay.
Bye.
Thank you.
Thank you. Bye-bye.
Bye-bye.